Toyota's approach to carbon neutrality is commendable, as they have been at the forefront of eco-friendly vehicles since the introduction of the Prius in 1997. With a growing concern about carbon emissions and their impact on the environment, it is crucial to explore alternative technologies that are sustainable and eco-friendly. Toyota, unlike other car manufacturers, has not made the transition to producing only electric vehicles. But why? Well, the company is betting that their game-changing engine innovation has the potential to change the automotive industry. Hello, and welcome to E0, the channel where we cover electric vehicles news, updates, and content. Today, we're going to talk about the reasons why we think Toyota has not gone all electric, but rather decided to go in a different direction with its fascinating hydrogen combustion engine. Let's first go back to where the idea of hydrogen engines all started. Toyota is not the first company to develop hydrogen engines. The idea of using hydrogen in internal combustion engines was experimented with as early as the 1800s. German automaker BMW was one of the pioneers in the modern era, introducing a hydrogen-powered internal combustion engine in 2002 with the BMW 750HL. It was followed by the BMW Hydrogen 7 in 2005, which ran on both hydrogen and gasoline, making it a dual-fuel engine. However, BMW's efforts with hydrogen internal combustion engines were limited, and only a few experimental models were produced. While hydrogen internal combustion engines had been experimented with earlier, hydrogen fuel cells have a different mechanism and were also explored independently. The development of hydrogen fuel cell technology traces back to Sir William Grove in 1839, when he first demonstrated the principle of the fuel cell. However, it wasn't until the mid-20th century that significant progress was made in fuel cell research and development. General Motors, GM, is credited with making notable advancements in fuel cell technology during the 1960s and 70s. Now, back to the future. Today, Toyota is a prominent automaker that has heavily invested in both hydrogen fuel cell technology and hydrogen internal combustion engines. Toyota introduced its first hydrogen fuel cell vehicle, the Toyota Mirai, in 2014, which uses a fuel cell stack to generate electricity to power its electric motor. Subsequently, Toyota has been actively working on developing hydrogen internal combustion engines as well, as showcased in their hydrogen combustion engine-powered concept cars like the GR Corolla H2. So, what exactly is the H2 engine? The H2 engine refers to Toyota's hydrogen combustion engine technology, also known as the hydrogen-powered internal combustion engine. It is a type of engine developed by Toyota that runs on hydrogen fuel rather than traditional gasoline or diesel. The H2 in the term stands for hydrogen, the primary fuel source used in this engine. Unlike conventional internal combustion engines that burn gasoline or diesel to produce mechanical energy, the H2 engine utilizes hydrogen as the fuel, which undergoes combustion with oxygen to generate power. This combustion process releases energy that drives the vehicle's wheels, providing propulsion. Now you have a better understanding of what the hydrogen combustion engine is, but why hydrogen as a power source? For starters, hydrogen is the most abundant element in the universe. It offers numerous advantages as a power source. It has the highest specific energy density among non-nuclear power sources, making it a viable option for vehicles. Unlike traditional combustion engines that emit harmful pollutants, hydrogen engines only produce water as a byproduct, making them a cleaner and greener solution. Just imagine a car releasing only water as a byproduct instead of CO2. That should make the environment happy. Being abundant, hydrogen can be produced from various sources, including renewable energy such as solar, wind, and hydroelectric power. This diversity of production methods ensures energy security and reduces dependence on fossil fuels for transportation. Another major benefit of hydrogen engines over electric vehicles is their longer range and faster refueling times. Electric vehicles face challenges related to charging infrastructure and longer charging times, which can be inconvenient for drivers. Hydrogen-powered vehicles, on the other hand, can be refueled in just 90 seconds, making them comparable to traditional gasoline-powered cars in terms of convenience. Moreover, hydrogen-powered vehicles have a smaller battery compared to electric vehicles, which reduces the reliance on rare metals like lithium and nickel. These limited supply materials are crucial components in electric vehicle batteries, and reducing their consumption can have a positive impact on resource sustainability. Hydrogen storage systems, such as high-pressure tanks or cryogenic containers, can be lighter than batteries used in electric vehicles. This weight advantage can have a positive impact on vehicle efficiency and performance. In addition to being more practical and sustainable, Toyota's hydrogen combustion engine also addresses safety concerns. The company has taken measures to ensure the safety of their vehicles by reinforcing critical components and adopting gas-fueled fuel injectors. These enhancements give drivers the confidence to embrace hydrogen-powered vehicles without compromising on safety. Finally, here's another cool benefit. Hydrogen combustion engines have the advantage of being compatible with existing internal combustion engine technologies. This compatibility allows for the potential retrofitting of conventional gasoline-powered vehicles to run on hydrogen, offering a pathway to cleaner transportation without the need for entirely new vehicle designs. Now, it would be unfair to talk about the hydrogen engine's amazing benefits without talking about the limitations and challenges that need to be addressed to realize their full potential. One of the most significant challenges is the storage and distribution of hydrogen. Hydrogen has a low volumetric energy density, meaning a large volume of space is required to store a sufficient amount of hydrogen for practical vehicle range. Compressed hydrogen gas, or liquid hydrogen storage methods, require specialized infrastructure, and creating a comprehensive hydrogen refueling network is still a significant obstacle in many regions. Also, the lack of an extensive hydrogen refueling infrastructure makes it difficult for consumers to access hydrogen fuel conveniently. Without a widespread network of refueling stations, the adoption of hydrogen-powered vehicles may face challenges in terms of practicality and consumer acceptance. The production of hydrogen itself can be energy-intensive, and the primary methods used, such as steam methane reforming or electrolysis, may still rely on fossil fuels, impacting the overall carbon footprint of hydrogen as a fuel source. To fully capitalize on the environmental benefits of hydrogen, its production must transition to renewable energy sources, such as solar, wind, or other sustainable methods. That's not all. Hydrogen technology, including the infrastructure and fuel cells, can be expensive to develop and deploy. As a result, hydrogen vehicles often have higher initial costs compared to traditional gasoline or battery electric vehicles. The cost-effectiveness of hydrogen as a fuel option remains a significant concern for widespread adoption. Hydrogen is highly flammable and has specific safety concerns related to storage, handling, and refueling. While safety measures are in place, addressing these concerns requires proper training for first responders, public awareness, and stringent regulations. Finally, despite being a cleaner option compared to traditional internal combustion engines, hydrogen combustion engines may produce nitrous oxide, N2O, as a byproduct. Nitrous oxide is a greenhouse gas and can contribute to air pollution if not adequately controlled. That will not make the environment very happy. Despite these limitations, ongoing research and development efforts are focused on addressing these challenges and improving the viability of hydrogen combustion engines. In fact, real-world testing and evaluation of the Corolla Cross H2 concept car are already underway in northern Japan. With the Japanese government's ambitious plans to have a substantial number of fuel cell-powered cars on the road by 2025 and more refueling stations in the pipeline, Toyota's hydrogen technology seems to have the necessary support to make a significant impact in the automotive industry. Toyota's commitment to a diversified carbon neutrality approach and the development of hydrogen combustion engines show their dedication to finding comprehensive solutions to environmental challenges. They acknowledge that there is no single solution to reducing vehicle emissions, and investing in various technologies is essential to meet the diverse transportation needs of customers worldwide. The benefit of hydrogen engines extend beyond just environmental advantages. The quick refueling times and longer ranges make them a feasible option for long-distance travel, addressing some of the limitations of electric vehicles. Additionally, hydrogen engines can contribute to energy security by using surplus renewable energy to produce hydrogen, ensuring a stable and reliable energy supply. As Toyota continues to refine its hydrogen combustion engine technology and works towards commercializing it, the automotive industry can expect a transformative shift. Hydrogen-powered vehicles offer a compelling alternative to both traditional internal combustion engine vehicles and electric vehicles, bridging the gap between convenience, sustainability, and performance. In conclusion, Toyota's pursuit of the hydrogen combustion engine is a testament to their commitment to innovation and environmental responsibility. This technology has the power to revolutionize the automotive industry by providing a cleaner, more sustainable, and efficient transportation solution. With their ongoing research, testing, and collaboration with other industry players, Toyota is poised to lead the charge towards a greener and more sustainable future in the automotive sector. As we eagerly await the commercial rollout of Toyota's hydrogen-powered vehicles, it's clear that the automotive landscape is on the cusp of a transformative and eco-friendly revolution. Thanks for watching this video. We hope you learned something new and interesting. If you did, please leave a comment below and let us know what you think about Toyota's hydrogen engine and the future of EVs. And don't forget to subscribe to our channel and hit the bell icon to get notified whenever we post a new vid. Until next time.